Assalamualaikum warahmatullahi wabarakatuh. My name is Nora Ain Amilah Syamira binti Muhammad Amir, and this is my group members, which is Muhammad Faiz Haikal bin Muhammad Zaini, Nur Anira binti Syamsul Johari, and Nur Aqilah binti Yahya. So we chose Tealive Tapah to be observed for the queuing system for this project. So the situation is Tealive Tapah receives 17 customer per hour in average. So it takes about several minutes per customer in average for the cashier to ring up the sales and form a single line for the customer to pick the cashier. So how many people typically are waiting in line? So for the introduction, we choose location in Tealive Tapah, Perak, which is near to UiTM, and the operating time, which is 10 a.m. until 10 p.m. So we had choose for the observation time, which is 12 p.m. until 1 p.m. and the number of server is one only. Okay, as you can see, this is a photo of situation, which is Tealive kiosk and a queuing of customer in Tealive Tapah.
Arrival characteristic. For Tealive Tapah, the size of calling population is unlimited or infinite because Tealive Tapah is food and beverage restaurant that receive unlimited customer. As they receive unlimited customer, their arrivals are considered at random because their arrivals and occurrence cannot be predicted. During the data observation that we did, we can see that most of Tealive Tapah customer having a patient during queuing. Next, I will proceed with the waiting line characteristic. Tealive Tapah has limited length of line, which is 15 customer per time. The limit of restaurant space affecting the length of a line. Besides that, Tealive Tapah applied first in first out queue discipline as how other food and beverage restaurant applied. The first one customer who queue and ordered, they were the first one who leave the premise as they have been served.
Next, we move to 2.3, which is service facility characteristic. We have three characteristics here, which is number of channel, number of faces, and number of waiting line. Okay, the first one is number of channel. We have single channel system, which is S equal to 1, and number of faces, single face system, and the last one is number of waiting line. Still single waiting line because of we choose for the single server, so the number channel, faces, and waiting line is still single.
Next, as I mentioned before, basic queuing system configuration for Tealive Tapah is single line and single face system. To make it clear, I will explain how it works at Tealive Tapah. Firstly, the customer need to wait in a queue till being served by a server and wait for their order to be ready because there is only one counter only. So here, the customer who order first will be able to get the order first and leave the store. Therefore, first in, first out in this situation are satisfied.
Assalamualaikum. Hi. I will explain here about the result we get based on our observation at Tealive Tapah. So, but before that, I will explain the meaning of the symbol in the slide. For lambda is arrival rate, and for the mu is service rate. So, all the equation we use in the slide is per hour. So we go to the first result, the average number of customer in the queue. For the formula is LQ equal to lambda square over mu open bracket mu minus lambda close bracket. So for the average number of customer in queue, we got 4 customer in queue. So for the next is the average number of customer in the system. The formula is L equal to lambda over mu minus lambda. We get 5 customer has been served in the system. And we move to the next result, which is the average time customer spend in waiting queue. This result show the length of time for the customer to organize before being served. So the formula is WQ equal to lambda over mu open bracket mu minus lambda close bracket. So the result we get for the average time customer spend in waiting queue is 17 minutes. So for the average time customer spend in the waiting queue is 70 minutes. Next, the formula for the average time customer spend in the system is W equal to 1 over mu minus lambda. So the result we get is for the average time customer spend in the system is 20 minutes. 20 minutes customer spend time to wait until get the Tealive water and exit the store. That's all from me. Thank you.
Last but not least, for the conclusion, is the numbers of service provided adequate? The answer is yes, because the customer are being served with service rate more than arrival rate of customer. And then, are the customer happy with the waiting time? Yes, they will be happy because no need to wait too long to being served. And we can conclude that if mu more than lambda, the service provided are enough to serve customer at a fast rate.